All right, the last thing we're going to look at is this idea of synthetic division. You'll catch on to this quicker than the long division, but there's some very particular things that go along with it. It's basically a shortcut to long division. So fancy math definition, it's a process whereby the quotient remainder can be determined when a polynomial is divided by some g of x, x minus c. The key is it has to be a linear function. So synthetic division will not work for this problem or for this problem. Okay, you have to do long division. It has to be a linear. Now, the whole idea behind this is, what if you take two linear things? So let's say x minus 4 and then x plus 6. You double distribute these, and you get here. Now, let's say I started you here, and I said solve this problem. You guys would all factor it up to here, and you would tell me the solutions are 4 and negative 6. So these two numbers make this quadratic go to 0. That's what synthetic division is going to let us do. Okay? So now, I would hope you would agree, if I took this right here and I did long division by x minus 4, I would get x plus 6 left over. Okay? So these two things right here are factors of this polynomial. They go in there evenly. It's the same idea as 24 is the same thing as 8 times 3. 24 divided by 8 is 3. This quadratic divided by an x minus 4, if you did long division, gives you x plus 6. Okay? Synthetic division is going to give us a shortcut for it. Here's some helpful things for it. You have to use zeros as placeholders. Okay? All the degrees have to be counted for. In long division, you'd find out things didn't match up, so you would realize it if you forgot. In synthetic, if you forget, you're just kind of out of luck because we're not actually going to use the variables. Most importantly, do the opposite of what, or use the opposite of what they give you. So if they ask you to divide by x plus 5, you're using a negative 5. In the same way that 4 is your solution to this quadratic, you're using the opposite. It's basically a way to find solutions. Third thing, drop down the first number and multiply and add. Okay, the first two things don't make sense until you see it, but we don't have to flip the signs anymore. We're just adding. Okay, so you don't have to flip. That's only with long division. Now you can only use it when the divisor is the first power. So you see that again. Okay, it's only with linear functions. So here's this problem right here. Use synthetic division to form the indicated operation. Take this polynomial, divide it by this linear. Okay, so we set up the bar, kind of the same idea. Now we put our numbers in. We don't care about the variables. There's no x squared term, so make sure you use a 0 as a placeholder, negative 11, and a 1. So now, 5th, 4th, 3rd, squared, 1st, constant. So we have them all. You can double check. If we're dividing by x minus 4, what's the solution? The solution is 4. So that's what you're dividing by. Okay, here's what I mean by drop the first term down and add. Drop it down and leave a space, like leave this whole row blank, because that's where some work's going to go. And now we multiply up and we add. So it looks like this. You multiply up, 8, add straight down. Multiply up, 12, add straight down. Multiply up, add straight down. Multiply up, add straight down, so 229. 229 times 4 should be 916. Add straight down is 917. Okay, here's how you read this whole thing right here. Now, this will always be your remainder. This will be your constant term. So that's the term with no x's. This is x squared, x cubed, x to the fourth. But if you think about it, you're putting an x into an x to the fifth, you know you need an x to the fourth. So here's how you'd write your answer. The numbers in here tell you everything you need to know. So I have 2x to the fourth, 3x cubed, 15x squared, 60x plus 229 with a remainder of 917. Okay. Now, if you did long division, you would get the same thing right here. So basically what we're saying is, if you take all of this down here in the black and you multiply it by an x minus 4, you add in your remainder, you should get the original. But this is just a shortcut for long division. You can see how much quicker that went. I can check that in the calculator and make sure I did that correctly. Okay, so I'm going to pause it real quick and get that typed in. So if we think we did this correctly, remember we're taking our answer down here, multiplied by an x minus 4, then adding in our remainder, and we should get the original. Okay, so we punch those in. No need to plug in the 0 placeholders up here. We can just do the original. You go to the table, it all matches up, so you know you did it correctly. Okay, let's look at another example. Synthetic division can be used to determine whether that thing we divide by is a factor of the given polynomial. But the key is the remainder must be 0. So if you think about what we just did, x minus 4 would give a solution of positive 4. But clearly that is not a solution because you got a huge remainder. So if you plug a 4 in here, it does not solve it. Synthetic division lets us basically solve equations. Okay? If you go to a 4, we get 917. That's what our remainder is. Okay? It is not a solution. Synthetic division lets us figure out whether or not things are solutions. Okay, so if x minus 3 is a factor of this thing right here, you're basically saying, does this thing to the 6th power factor, to a bunch of different things with one of them being x minus 3? Now, you could try all our different factoring methods, but something to the 6th power there could get pretty dicey real quick. So we're going to do what the problem tells us. If you have an x minus 3, that means your solution is positive 3, so that's what we're going to use. Now, notice there's no x to the 5th term, there's no x cubed term, and there's no x term, so we need zeros. 2, 0, negative 18, 0, 1, 0, negative 9. Okay, drop the first number down, multiply up. Drop this down, multiply up. This is your remainder. If you get a remainder of 0, that means this checks out, that actually is a solution. So here's what's left over. The question is, determine whether this is a factor. So you would say yes, because the remainder is 0. Now, if you wanted to write this polynomial, if you're just doing a division problem, remember this is your constant, so plus 3. This is your x. Here's x squared, cubed, 4th, and 5th, because we started with the 6th power. So then you got 2x to the 5th plus 6x to the 4th plus an x plus 3. You don't have to count those in there anymore. Okay, but your answer is yes there. Okay, so there's 2 examples on synthetic division. We'll go through a couple more in class tomorrow and practice this skill. And then that's a wrap on everything through the first 5 sections of the appendix. And it is a lot, so we'll work on putting that all together before our test. So bring questions you have on this to class tomorrow.